Hi and welcome to Maths class. Today we're looking at integration of circular functions. So what we're going to do is learn the rule to integrate circular functions, and then we're going to look at some definite and indefinite integral worked examples. So we'll just start by going and remembering what we know about differentiation of circular functions. And if you remember, when I differentiate sine, I get cosine. When I differentiate cosine, I get negative sine. But also, if my sine function has kx plus a in the brackets, then my derivative will have a factor of k, which is the coefficient of x, out the front. So what this means, if this is the function and this is the derivative, then if this is the function, this is the antiderivative. So I can write down the antiderivative of k cos of kx plus a dx is going to equal to the function I started with, which is sine kx plus a. And let's throw in our plus c, don't forget that guy. Now I don't want to know the antiderivative of k cos kx plus a. I need to know the antiderivative of just the cos part. So I'll divide, this is a constant term, a constant factor, so I can put it out the front, which means I can just divide both sides of my equation by k. So that will leave me with the antiderivative of cos of kx plus a dx equals 1 on k sine kx plus a, and again plus c. So one of the things that's nice about the integral of cos is that we're starting to see a pattern here. And the pattern is when I differentiate and I get a factor of k out the front, I have to multiply my 1 on k. So just like in differentiation, we start to see similar patterns. The linear function inside the cosine is not affected, so it doesn't change. So the only thing we have to remember is the plus c. And the other thing we have to watch is the fact that the derivative of cosine gives us negative sine. The antiderivative of cosine gives us positive sine. Okay, so let's look at how this works for cos kx plus a, and it's a very similar thing. The derivative of cos kx plus a is negative k sine kx plus a. So that means that the antiderivative of this is going to be cos kx plus a. So I write down the antiderivative of negative k sine kx plus a dx is going to be cos of kx plus a, and throw in our plus c on the end, of course. And in the same way, I just need to divide both sides of my equation by negative k. So that's going to give me sine of kx plus a dx is negative 1 on k cos of kx plus a plus c. Oh, sorry, you couldn't see that. There we go. So the important thing then to remember again is that when I take the antiderivative of sine, I'm going to get negative cosine. And again, I'm going to divide by the factor of k. That's the coefficient of x there. So here's my first worked example. I need to find an antiderivative of 8 cos 4x plus pi on 2. So let's just rewrite the question mathematically. Instead of find an antiderivative, I'm simply going to write down the antiderivative or the integral symbol, 8 cos of 4x plus pi on 2 dx. So the antiderivative, let's go back to our rule, the antiderivative of cosine kx plus a is 1 on k sine kx plus a. So I'm just going to write down, well, first of all, I'll keep this 8 times 1 on the coefficient of x, which is 4, times sine of 4x plus pi on 2. Throw in a plus c because it's an antiderivative. I'm not doing a definite integral like I am in the next one. And then we simplify 2 sine 4x plus pi on 2 plus c. So again, notice that this part in the brackets has not changed at all. This pi on 2 didn't do anything to the antiderivative at all. In example 2, I'm going to calculate the exact value of the integral from pi to 2 pi of sine x over 6 dx. So I'm going to go straight into finding the antiderivative. Open up my square brackets. The antiderivative of sine, let's go back to the formula. Oops, I've scribbled on it. The antiderivative of sine is negative 1 on k cosine. But, so k in this example is 1/6 because I've got x over 6. So this is 1/6 x. So if I divide by 1/6, it's going to be the same as multiplying by 6. So I'm going to have 6 cosine, oh, and it's going to be negative. Negative 6 cosine of x on 6. And I'm going from pi to 2 pi. All right, so now I need to do my substitution. I'm going to substitute in the top terminal first and then subtract with the bottom terminal substituted in. So I start with negative 6 cos 2 pi on 6, and then I subtract and then substitute exactly negative 6 cos of pi on 6. And now I can see that I'm just going to need to find my exact values. So what I'm going to do now is rewrite this as negative 6 times, well, this is cos pi on 3. Cos pi on 3 is a half. And this will be negative of a negative, so that's plus 6. Cos pi on 6 is going to be root 3 on 2. And then I'll just collect those together. This is going to be negative 3. And this is going to be plus 3 root 3. And that's the exact value, which is what I was asked for. So I'm not going to grab my calculator and put that in. So what I want to just take a moment to do now is make sure that you guys know how to do this using your CAS calculator. Now, if I try and do it on my CAS calculator for you like that, it's not going to be very clear. It's all reflecty and whatever. So I'm going to use my computer version. So there's my CAS calculator. And in fact, I'll go back just for a moment to the question. Come back, there it is. I'm not going to try and enter this or enter this into my CAS calculator. I'm going to go straight to the beginning and calculate the integral and put in my terminals and get straight to the answer. So what I want to do is I need to enter an integral, and this is what that's going to look like. Hang on, there it is. Okay, so this is in your keyboard. You can see it's in Math 2, and right there you can see circled is the integral symbol. And so I'm going to click that, and that's going to make it appear in my calculator. So there it is. And now what I need to do is go ahead and enter all the information that I need. So I'm going to go from from pi to 2 pi. So I'm up at 2 pi here. So I enter 2, and there's pi in the same window. And then I go down to here, and I need pi. And then here I'm going to enter my formula, which is sine x on 6. So sine, and then x on 6. And I'm going to want dx. And I hit enter. And there it is. So I've got 3 root 3 minus 3. And if you remember, the answer I found before was negative 3 plus 3 root 3. It's the same answer. No working shown at all, but the same answer. So if I'm in a tech active exam, then I'm allowed to do that, all right? But of course, if I was asked to do this, then they wouldn't ask me that question in a tech active exam. But I might be in a situation where I've done something to come up with this and I need to calculate it. That's how I put it straight into my CAS. So that's an introduction to integration of circular functions. There is going to be one more video when I'm going to do an area worked example, and I'll just put that straight after this video.